Uh, Thanks for everyone for being here. So for those who are not familiar with me, just quickly, I've been doing research in AI for about 10 years before blockchain. And I actually was working with Noah before at Google, working on TensorFlow, as well as a few other projects. And I led a team working on natural language understanding and question answering, and worked with Lukáš on Attention is All You Need, the kind of paper that introduced transformers. Now, I left Google in 2017 and started an AI startup because I thought this model, transformer model, now is able to teach machines to code. And to me, that's a very fundamental kind of change on how we interact with computing, because if machines are now able to write code and to effectively program themselves, we don't really need for software anymore. Now we just have a conversation, and machines just kind of materialize code as they need to on the fly. And we'll talk about what this means. Now, 2017, that sounded a lot like science fiction, and somewhere between delusion and science fiction. It didn't really work yet. We were trying to get a lot more training data for our models, and so we had a lot of computer science students around the world who would actually do small tasks, write documentation for functions, write some code based on descriptions. And we had challenge paying them, right? This was students in China, in Eastern Europe, in Southeast Asia. All those countries have some kind of monetary restriction. Students usually don't have bank accounts in China, for example, so we needed to have like WeChat Pay to send them money. In Ukraine, you need to sell automatically half of the dollars you receive. So there's all kinds of challenges. And so we actually started looking at blockchain as a way to solve our own problem. How do we pay people, contributors, for this data collection at scale in an easy and automated way? And so looking around, we haven't found anything back in 2018 that would actually solve our problem, right? Nothing that would scale, that would be cheap enough for us to use, and it would be actually easy to develop and use on. And that's how we started Near Protocol. And so Near Protocol is one of the kind of most used blockchains right now, been on mainnet since 2020. But over the past kind of year or so, we've been focusing a lot more on how do we really kind of bring back this AI vision, because from my perspective, AI is the last wave of technology, right? Fundamentally now, we already see that AI is going to be effectively the tool that we're going to use to do everything else, right? Already we see Nobel Prizes in chemistry and physics are given to AI researchers. The mathematics kind of is being now done with the augmentation of AI tools, right? Whatever coding you do, whatever other jobs you do, they all are now driven or kind of done by AI. And you can imagine this starting to compound to a level where effectively all of the new innovations are coming one way or another through the AI tooling. And what this means is whoever controls these AI systems, whoever effectively can bias it in any way, controls all of these different aspects of our life. So that's a very kind of strong statement, but the challenge is we're moving in that world really quickly, where we only have a handful of these companies that are effectively at the forefront of AI research and effectively controlling how people are interacting with computing going forward, because all of it is done through AI. And so the alternative we framed is user-owned AI. It's alternative that is really about how AI is effectively optimized, not how to not the business model underlying, right? Right now, AI is optimized for success of individual companies, right? Like if a company A trains a model, they're effectively one way or another eventually want to generate revenue for that company, right? That is just like the optimization function of the corporate system. And so what is a different model where the value function is actually on the user side, right? On the success of individual user and their well-being and their economic success, versus on success of this few corporate entities. And so that's kind of the idea of user-owned AI, really to flip the script on the incentive structure and value function of this whole system. And so as part of this, there's a paradigm shift that's happening, right? So kind of internet actually kind of converged into this really interesting place where, it started as like, hey, there's lots of web pages everywhere, everybody's navigating them, that really converged to a few different aggregators, right? Google's and Amazon's, Uber's and Instacart's, that effectively are aggregating all of the content and, kind of own the distribution, own the eyeballs, and effectively mediating that by generating revenue for themselves. Now, we already see this kind of starting to transition where you now have agents kind of doing different things, right? And this is just starting, but where agents now can go and like do actions and do things on websites and maybe interact with other agents. But kind of the transition I see happening in the future is really where the apps and websites are disappearing themselves, right? Because they're effectively just a materialization, right? This is some code that was written by someone of some interaction that you want to do with some other third party. And so you can imagine a very direct interaction where your AI is now talking to another third-party AI, be that a restaurant directly, a factory, a pharma company to get a medicine, and really kind of communicating your exact needs. Instead of going through Google and getting 10 blue links, right? It can go and scan every single option on the internet and find the best option for you, because it can score them, it can evaluate them, it can interact with them at scale. So that's kind of the agent network where this transition is happening. So in this transition, right, where we're going from kind of this search to what we have now answers to actually action, we need to ensure that we have utmost confidentiality, right? Like your AI agent, your AI assistant will have kind of maximum context about you to be able to be the most effective, right? It should know everything about you. It should be able to, potentially even listen to your conversations in day-to-day to be able to predict what you want and be able to represent you on the internet in front of others. We need to have this kind of access equal for everyone, right? You cannot have that, like, people in some countries don't have access to this, or there's like, somebody can flip the switch and turn off some subset of users from accessing this. And we want users to own the kind of their own assets, data, and power of choice to really continue being in control of the system, not effectively being manipulated by it. So for those who were earlier, that's what Vitalik was talking about, having kind of AI on your side that actually can represent you and can filter down information to prevent you from being manipulated. So this is a lot of like, okay, this is like bright future. What does this actually look like? So this is just to give you a very kind of clear use cases, right? So this is, now your AI assistant is controlling your phone. Instead of you going and booking a flight or you going and, sniping concert tickets, you just have your AI assistant running on background, knowing that you like, for example, I like metal concerts. There's one coming out next weekend, so it went and grabbed the tickets as well as soon as the ticketing opened, right? As well as, on the financial side, it can go and rebalance the portfolio between different lending protocols based on, again, seeing that there's a better opportunity and it maintains the same risk profile that you're already taking. So you effectively have this not just like prompting and kind of doing actions on you, but actually running actively and finding the opportunities and like what things you would have done and executing that on your behalf, right? And understanding what is the best option for you. So how do we do that? What is actually needed to achieve that, right? Because we don't have it right now. Well, there's a number of key features that we need. First of all, we need a confidential and secure system where we can host these agents, right? These agents, like they're going to be anyone can develop them, and so we need a way to really make sure that all of them are secure and confidential, the data is not leaking, that you're able to interact with them in this secure way. You want a way to make sure all of the data, user data, enterprise data, etc., are kind of linked up and haven't shared memory. You want to make sure that you can find agents that are able to do the exact task you want to do, right? So there's a discovery process to find the agent for the specific task, and you want a way to pay and kind of really transact with these agents, for example, as requesting something to be done. So on the confidentiality side, right, again, I'll just kind of rehash this because for this AI assistant to be kind of have maximum utility for you, we will need to give effectively the most information, right? It will be your banking information, your medical information, your crypto, your day-to-day, your job, etc. And like we really cannot trust any single company, right, including ours, with handling this data. Like companies continuously lose data, companies continuously, have data leaks, cyber breaches, etc. Like we do need a system that is effectively can protect against any of this, and is guarantees that every user data is secure and confidential to themselves. So these agents are on your side. And so what we're introducing is a decentralized confidential machine learning cloud. It's a mouthful, but the idea is that you want a ability to run AI models and agents in such a way that only the end user is able to effectively initiate and run this and have an end-to-end encryption with the kind of node that's running it. And even the computer owner, right, that runs the compute is not able to access this data. Like not the kind of hardware provider, not the model provider, not the kind of software developers of the cloud itself are able to access this data. So the way this is done is by using so-called trusted execution environments. This is a special hardware module inside modern hardware that enables to effectively run computation on somebody else's device in the restricted mode, where the owner of the device is not able to access data and compute inside this module. And as of like 8 months ago, this now works together with NVIDIA GPUs. And so you're actually able to run kind of large-scale, model inferences in this mode where the end-to-end is encrypted. Now, you still have challenges around how do you actually find these devices, how do they need to page in all the relevant data, as well as you need to ensure that if that device goes offline, you're able to rotate and insert and use a different device. And so that's what kind of the confidential machine learning cloud is enabling across a number of protocols. If you're interested to learn more about this, there's a whole separate talk about how this works. Now, on top of this, we're building this agent hosting. And maybe a little bit hard to see, but effectively, it's a platform where you can, as simply as in Vercel, just deploy your agent, and now it runs there. You don't need to deal with DevOps. You don't need to deal with kind of any of the operations. It runs, if you specify the flag in this confidential mode so that every user knows that they have an encrypted connection with it, and you're able to effectively, as a developer, just kind of deploy it and leverage, if there's any payments or other monetization systems embedded into it. And as a user, you can now use this with all of the data and context you have. So we just actually crossed 600 agents on this platform. Now, the other piece I mentioned, right, is like how does this agent going to talk to each other? And so to give you an example, right, let's say I want to run a marketing campaign. I ask a marketing agent. It then goes and maybe finds a set of other agents or even people to participate in its marketing plan. For example, it needs some people to actually record TikTok videos. It needs another agent that can do Twitter placement. And so you need a protocol how this kind of communication, collaboration between different agents will actually be facilitated. And so that's what we use agent interaction and transaction protocol as AITP, meaning kind of AI HTTP, to really provide this communication on how different agents are going to talk to each other, how they're going to come to commitments, exchange information, and later, if there's any disputes or conflicts, there's going to be a process of resolving that and kind of coming to a consensus. And so in the simplest form, this is just a natural language exchange between different agents who are communicating to each other. And then there's a structured capabilities that agents can effectively exercise against each other, saying like, hey, I'm requesting some data. or I need a payment for this interaction. And so in the simplest way, right, you go into your AI therapist. The AI therapist says, no, pay me first for the session, or need to stream payments as we're interacting, and then you continue with your AI statements. In a more complex, maybe you exchange some information first, and then it requests information, delivery address, and then gives you a quote on how much it's going to cost to actually deliver the product. And so to give you a very specific example, this is something that's live right now, although it may be hard to see, is one of the agents we have is a specialized agent that knows how to buy equipment from Amazon, specifically sound equipment. And so it's called SoundSage. Now, as a user, you will not actually be using these agents directly. You will be talking to your AI assistant, right? That's on your side. It has your context. And as you're talking to it, right, it will at some point decide to venture off and to talk to other agents to execute your task, right? So in this case, I'm asking, shop for green headphones. It first responds based on its own kind of context and search. And then if I'm clarifying that I want cheaper headphones, it actually, okay, I need a specialist agent for that. So it opens up a subthread that is actually not by default visible to the user and converses there. And so the SoundSage agent actually responded with specific options of products that then you can directly buy from. So there's actually a full UI rendering that your assistant can do to show you kind of options, and then you can interact with it, as well as fill in specific information, which if your AI assistant already knows, it will just kind of fill in directly. And then from there, it actually requests for the payment to actually pay for the headphones. And so this is where you can effectively pay with any crypto and fiat as well soon. And this is actually using near intents and kind of on-chain transaction to really route the funds from any chain. Right? You can pay with stablecoin in any chain or any other asset available in your wallet. So that's kind of the idea, to just show you like kind of how all of these pieces working together, right? Your AI assistant found the right agent, talked to it on the background, gave you options, and then from there actually went and navigated and exercised payment between different agents. So yeah, to just kind of show you the schematics of this, right? User only talks to their AI assistant. The assistant can augment the request with maybe context, as well as when the options are coming, it can actually even decide sometimes on your behalf, right? Or pre-filter it or re-rank based on knowing your own preferences, right? Maybe it knows that you prefer some specific brand, and so it will prioritize that. So instead of usually having Google here, which effectively does the ranking and showing back to the user, now your AI assistant is effectively in front of you, being the interface. So to show you another example, this is actually built by the Datrix team here. Not everything will have an agent, and sometimes you want to do something kind of repeatedly yourself, and so this is actually an agent that builds agents, no-code agent builder. You can actually describe the specific interaction that you want to be built. So for example, here you want an agent that will fetch prices from CoinMarketCap and respond to kind of crypto pricing questions. And this effectively agent reads the documentation from this website, and then figures out how to build the agent yourself on the fly, right? So this is kind of the example where the AI itself now writes code for itself to then exercise in the process. And so kind of, I would say like the mental model here, code is becoming really more of a cache of some business interaction than just kind of permanent software. And the idea here, it kind of suggested the plan, the technical plan, how the agent will work. It will write the code, and it will deploy it back into the hub itself. And so now, not just you, but everyone can actually use this agent in their subsequent kind of queries, because the assistant will now find it. It also knows about API keys and kind of other relevant information, so that it will ask you to provide it. Now, sometimes there is no API and there's no kind of effectively agent to be built. And so in this case, you can actually have a full kind of operator system, right, that goes and navigates the web browser in the web, the application, and actually does the action on your behalf, right? So this is an example of using Airbnb, where you just say, hey, book me Airbnb, and it goes to the website and actually clicks through it and figures out how to do it for you, right? So between all of these three components, right, you effectively have specialized agents doing things. You have on-the-fly building agents for specific use cases, and you have going and doing actual actions in the websites on the behalf of user. You effectively can cover all of the different use cases that you want your assistant to do online on your behalf. And they can effectively combine in different ways where this can actually get the API key from the specific website and fill it into the agent builder. So the idea here is really to enable kind of the everything that assistant should be able to do and really cover 100% of different use cases, and then on the back end really support all of this between different protocols with payments, discovery, and hosting. Now, just a quick bonus agent is an agent that you can just send $1, and then 6 hours later it may send you more than $1. So this is the example of a fully autonomous agent that receives money from users and then deposits it into its own trading strategy, again using near intents, and then 6 hours later liquidates this position and returns money to the user. So fully autonomous agent runs inside this verifiable confidential computing cloud, and using kind of all of those tools, right? It's hosted on Near AI hosting. It's using kind of near intents as a payment strategy. So this just kind of to show you the breadth of this system, right? It can do anything from shopping and e-commerce to financial and trading to doing actions on the website to actually building software and kind of building business processes on the fly for the specific use cases. So let's look a little bit ahead, right? You have the assistant that learns your preferences and actually anticipates the needs. So you can imagine, kind of as I showed in the beginning, where the assistant is actually doing actions directly, right? Because it knows you will approve that. Like the more you effectively kind of agree to its suggestions, the more you prompt it yourself, the more it will know how to effectively predict and execute actions on your behalf. Obviously, it can start taking care of your errands, manage your health and finance, communications. As you integrate more of your tools and data into kind of its process, and then it coordinates a swarm of agents in the background, but doesn't get this in front of you, right? You shouldn't know that there's hundreds of agents actually running on the background, executing these actions. You're just talking to your AI assistant directly, and then it coordinates that complexity for you. So for those who are coming from a blockchain side, like all of this is actually built on a pretty deep stack of technologies, everything from scalable blockchain that Nir started developing in 2018. We have the chain abstraction that allows to really use any blockchain and kind of any asset. We have intents that are a framework for effectively receiving outcomes, achieving outcomes, be that financial or not. And then we have this infrastructure for secure computation, verifiable computation, confidential computation. Now, I'll just finish on a little bit further ahead, right? So it's really important that all the systems are extremely secure. And one of the kind of overall challenges we're going to face is with more code written by AI agents and by AI systems is that we're actually going to see more and more security vulnerabilities as well. And so one of the foundational kind of ideas is that the only way we're actually going to get to secure software is that all software is actually formally verified. Meaning for any interaction, right, when I'm calling an agent, when I'm depositing some money, I want that agent to prove to me that it will actually, for example, return as much money as I deposited or more. Right. So for simpler like interactions on chain, right, when you're depositing money into lending protocol, you want to know that you will be able to return, kind of withdraw at least as much money as you put in. And so that would be an extremely important component because this is how we're going to get to a higher quality of software overall and then also remove a lot of the kind of security vulnerabilities that are actually starting to stack up now because of the AI kind of coding process itself. Now, not everything is formally verifiable, however much I want that. And so there will be places where we will need to have a dispute and arbitrage process, where effectively there will be kind of different points of view that are subjective, where we need to actually have some third party to evaluate this and come up with a solution, right? This is why we have smart, like actual contracts and force majeure, everything. And so now the cool thing is AI can also help with that, and it can do it extremely fast, right? Traditionally, the court system is extremely slow and it's very expensive, and so we use it kind of rarely, and the contracts are trying to kind of pre-define everything ahead of time. Now you can use a lot more kind of interactive kind of arbitration process where the whole chat of the ITP can be effectively shared with an arbitration agent who can quickly evaluate if there's all the clauses covered and if there's any kind of potential shortcomings to the transaction you're taking, as well as there is need to escalate to kind of AI court, right? You can actually evaluate that really quickly as well. And then you escalate to real court if that doesn't work, right? So you can have kind of a lot of like faster moving systems with AI, which then escalate to a traditional court and legal system if needed. Finally, I kind of mentioned this in the talk with Vitalik, but we really need also models that we know what kind of went into when they trained, right? Because right now, even when you use open source model, they're actually not open source, they're open parameters models, and we don't know what went in. We don't know what, training data bias or potential vulnerabilities that were encoded in this, and so we don't know how this is going to play out when they're used in production. And so ideally, we have a community-owned model where people actually contribute resources and come together to build it in such a way that we know exactly all of the training data and training process that went into it. So that's also, I think, coming down, and one of the enabling factors will be the new Blackwell hardware from NVIDIA supports confidential computing on the cluster level. So right now with H100s, kind of the way we run it, it's on the machine level, and if you want to communicate between different machines, you do need to go through a slower networking and encrypt it yourself. And on Blackwell, they're actually going to expand the confidentiality mode to the whole cluster. And so this would enable to actually train the model full end-to-end, where you know that only this data went in, only this code was run onto it, and this is the model, this is the outcome of this computation. So there's a lot to work. I just showed you kind of some of the progress we made with Near AI and teams around it. There's a lot of folks contributing across the board. Some of them are here. Thank you. And we continue pushing towards this vision and really building more and more towards this. Thank you. I have 5 minutes for questions.
Thanks for your sharing. Just I want to ask, in your opinion, do you think that there will be a future where we don't have any apps or websites?
Yes.
And what's the time frame that you are thinking of? 6 months?
I think it's going to be a very gradual progression. I think actually within year and a half, you probably can have a fully AI phone which doesn't have any apps, and you can probably do 50% of everything you would normally do with apps. So it probably wouldn't be your only phone, but it will be enough. Maybe this will go faster, to be clear, because so far AI has been always faster than people expected. But I think half of the things you can definitely already not need the applications for within a year. And then it's every year it will be half more, so slow decay. But although with operator and with some of the agent building, maybe it's going to accelerate faster.
I had a question about the thing you showed about kind of booking tickets or doing something like that. Do you think how would you solve the scaling issue, because these are limited resources, and when your agents are running kind of decentralized, then there is a lot of network hops that is happening. So let's say for the next concert there will be 1,000 tickets, which would probably go out really soon. So if I'm depending on my agent to book it, how do I make sure that I get the ticket, and I don't really have any control on that, right? I'm just depending on my agent being faster than the other agents. So how do you solve that scaling issue for like limited resources?
Yeah, so for limited resources, I mean, I don't think AI is the solution. The blockchain is the solution, and you actually need to run auctions. Like that's the right way to do things. And maybe you can, whatever property you want to auction off, maybe it's not price, maybe it's representation or whatever, but you effectively need to run auctions for any kind of, you either discover market price or whatever other parameter you want to maximize on. And then AI is just your execution, right, from the other side. Like the way I kind of think of this, AI is your front end, right? This is how you interact with things. Blockchain is a back end that actually facilitates, settlement, execution, auctions, etc. And so if we're talking about, ticketing, the right way for every, highly contested ticketing system is to run an auction or to have a proper resale system. We're actually working on something with Hyundai Card in Korea, for example, on that exact NFT ticketing, because it solves a lot of the problems for that use case.
Just a quick follow-up. Do you still think that with differentiation, different kind of agents, maybe there's some industries providing agents that will guarantee that they have a latency less than 10 milliseconds or something. They will execute whatever you want to do within that time period. Do you think that's...
I'm sure in a shorter period of time there will be all kinds of things where people try to differentiate, but again, medium term, whatever somebody can build, somebody else will replicate by effectively talking to the AI to write me the code like that, and then place it in the same data center. So I think it's all going to be just a temporary differentiation.
Following on the question about the apps, I was wondering to get your take on the SEO for LLMs. What's going to happen in that growth?
Yeah, that's a good question. So SEO for LLMs. I think that this is one of the interesting spaces where on one side, we really don't want this to be a thing, right? But sadly, the way the current model is working, it's very much a thing. I think to me, the bigger problem is actually right now, let's say I want Near to be Grok to say that Near is the best blockchain. Well, getting a bunch of tweets on X, right, about that is effectively the way to do it, right? You effectively flood the training data that they use to prefer, whatever brand or whatever system you want. So I think we actually are already in this state where effectively if you want to affect the AI models, you kind of need to flood the training data or flood their contextual index with this. And so I think we'll need more and more ways to find kind of reliable sources of information, dedupe it, etc. There is some methods which you can do, again, with a variety of crypto economic incentives around that. But I think, again, short term, we're also going to be in a very weird spot with that, where people are going to be effectively affecting these models in all kinds of ways.
So you talked about the protocol of AI agents communication, because agents can basically communicate using natural human language. I'm wondering what's the main difference between those protocols for AI agents and the way how human beings communicate with each other. And I'm wondering what's the difference for now, and also what the difference will be if the models can learn more like human brain, they can learn while they are doing inference, or they have long-term memory and short-term memories. Please share your insights.
Yeah, so that's a really good question. So the question is effectively, why do we need a protocol if this model is already talking natural language? Or what is the difference? What does the protocol provide on top of it? And so the core part of the protocol I showed is natural language, right? It's effectively just how you create a quote-unquote email thread between all the agents and people who are participating in one conversation, right? That's a structure. And then within that structure is effectively adding just additional metadata around payments and other more structured exchanges, right? So even now, right, if you try to actually request a payment from each other in natural language, it's a very complicated and annoying process, right? And so the easiest thing right now is maybe sending like a whatever Stripe link or something like this. So that's effectively what this protocol provides, is like set of forms and payment links that agents can use that are just really fast moving and kind of really adopted for the agentic use cases. And then authentication and kind of like looping encryption, etc. around that. So that's kind of the idea, is like, yes, the core exchange of information happens in natural language. As models evolve, I mean, some form of that will continue because that's the most natural way for them to also communicate with us, as well as it's the most easy way for any other agent to then come in and like catch up on what happened, right? They don't need to like reestablish like, oh, they've developed their own language and now I need to understand what it is, right? Like it's easier if it's just like something that everybody understands, which, just defaulted to be English. Although Chinese is obviously more information dense. One more question.
Can you say a little bit about how the user provides their context to the agents and the privacy guarantees and the relationship to the T or lack thereof?
Yeah, so I'll start with privacy guarantees. So the idea is that effectively everything will be running inside trusted execution environment. So your user data is either encrypted at rest or only gets decrypted inside trusted execution environment. So neither developers, us or model providers or agent developers or hardware providers are able to access it. So that's kind of the overall guarantee. And so you actually have an end-to-end encrypted TLS connection with the exact server where your data is being decrypted. You're talking to it. There's a kind of payment enrolled into this payment channels. And then when you effectively close the channel, right, it deletes everything and kind of resets its state. And so how you provide this then data is effectively, either like you have your private data kind of plugged into the agents specifically. So let's say you have your Gmail agent that you effectively authenticate, so it has access to reading your data from Gmail, and now it's able to continuously on the back end run scan every email as it arrives, decide if it wants to respond to it, or maybe prepare a response, etc. Right? This can be something that you provide just within the conversation itself with an AI assistant, and this can be something that you effectively, again, give it, like it goes and tries to do something and it comes back and asks you for some credentials and information, right? So you have like agents that kind of hold access to some kind of within the session, within your session, hold access to some data sources. It can be your personal data within the context, or it can be something that's needed for like specific execution or specific action, right? So variety of things, but the point is that all of this kind of always attached to your near account and kind of your credentialing system to near account, and then everything else like only gets like accessed by code inside the trusted execution environment. I think we're sorry. Thank you.